Okay, let us finish the page and then we can be done. Alright, so we are on number 8. What is the speed of a wave that has a frequency of 200 hertz? Go ahead and underline that, and a wavelength of 0.5 meters. So, first things first, we always label what we got. So I'm going to put my frequency equals 200, Hz, and my wavelength, that's that little weird Y-ish symbol, equals 0.5 meters. I don't like putting 0.5, it annoys me, but you do what you got to do. Alright, so easy money, easy formula. So our formula is velocity equals wavelength times frequency. So let's write our formula with no numbers. Velocity equals wavelength times frequency. Now we plug it in. Velocity equals, oop, I messed up. YOLO. Let's just do it. Do it again. Velocity equals, my wavelength is 0.5, parentheses, my frequency is 200. That's just pretty much half, so that means half that. So my velocity equals 100 meters per second. That's my units. Awesome. I box my answer. Easy, done. Alright, so number 9. From 9 on out, we got to use a bunch of different formulas, so we got to make sure we label everything. Waves are observed to splash upon a rock at the shore every 6 seconds. The distance measured from crest to adjacent crest is 8 meters. The distance measured from the lowest to the highest point is 10 meters. Lowest point, highest point determines, this is what we got to figure out, frequency, wavelength, and velocity, speed, right? So, ooh, somebody's calling Miss Cole. I'm not going to answer it. I'm not going to do it. Alright, so first things first, crest to crest. That's straight up our wavelength. So I'm going to label that off to the side. It's my weird wavelength symbol equals 8. I got to figure out a better looking symbol, but 8. So 8 meters is our wavelength. Easy. Now, our frequency, remember, our frequency formula is 1 over our period. And we know that it says, Mr. Barris, not here. I think she went home early. I'm trying to record a video though, so I'm kind of ruining it. It's okay. Goodbye. It's not okay. You ruined my video, and you got to be punished for that. All right. Okay. 1 over the period. So it said, yo, the waves are observed to splash on the rocks on the shore every 6 seconds. That's our period. So our period is 6. We don't need that, but I'm going to put that here. T equals 6. We don't directly need it. We do indirectly need it, which means my frequency is 1 over 6, because that's my formula, right? So my frequency is F equals 0.167. So, and that's hertz, right? 167 hertz. So right now we've got our wavelength, we've got our frequency, and we need our velocity. So, same deal, velocity formula. Frequency times wavelength equals velocity, right? Let's write it in. Velocity equals 0.167 times, there's my point, times my wavelength, which is 8, and that gives me a velocity of 1.3. Repeating. I'm going to box that. So I'm going to put it over here. Velocity equals 1.3. Put my line over top. So 1, 2, 3, 4. And really, we could, if we wanted to, we could do amplitude. Distance, all right, lowest to highest point is 10, which means my amplitude is 5, because it's the middle to the top and middle to the bottom. All right, number 10. The period of a wave is 0.03 seconds. Awesome. I'm going to put my line here so there's no confusion. My period equals 0.03 seconds. I'm going to go ahead and figure out I'm just going to start figuring stuff out before I even figure out what they want. My frequency, again, right here, 1 over period. So 1 divided by 0.03 is 33.3. So our frequency is 33.3, and that's hertz. It's traveling at a velocity of 10. Velocity equals 10 meters per second. Determine the frequency and the wavelength. Awesome. Well, I've already done the frequency. Did that by wavelength. So, formula, velocity equals frequency times wavelength. Well, I have my velocity, 10 equals, I have my frequency, 33.3. Wavelength, I don't have, but that's okay. This is an easy formula, right? 10 divided by 33.3 divided by 33.3. I know it's kind of sloppy. And calculating 0.3, my wavelength. I'm going to box it since it's over here. Am I doing this? I'm not doing this wavelength symbol right, but you know what? We're going to go with it. My wavelength equals 0.3 meters. Cool. Good. So we did that one. Easy. All right. Number 11. I'm going to put my line here because it's going to get jumbled. They don't give us a lot of room for all this stuff. A wave having a wavelength of 4 meters. Awesome. We have our wavelength. So our wavelength, I was doing it upside down. Oops. 4 meters. So I have that. Amplitude of 2.5. Amplitude equals 2.5. Travels a distance of 24 meters in 8 seconds. So it travels 24 meters in 8 seconds. So let's do velocity is distance divided by time. There's another velocity formula. Velocity equals distance over time. Our distance is 24. Velocity equals 24. Our time is 8, which tells me our velocity equals 3. Velocity equals 3 meters per second. All right. Determine the frequency and the period. Okay. Well, let's go back to our formulas. Velocity equals frequency times wavelength. Our wavelength is 4, and our velocity is 3. So 3 equals frequency times 4, which means divided by 4. Hopefully you guys can see that. Cancel that. Divided by 4. Frequency equals 3 divided by 4. 0.75. 0.7. That's not a 7. 0.75 hertz. Awesome. So there's our frequency. And you know the formula we do to find period. Period equals 1 over frequency, which means period equals 1 over 0.75. So our period was going to be, I'm going to give us a line here. That's our little bit of space. Period equals 1.3, and we know period is in seconds, so I'm going to box my answer. I always want to box answers. That way I don't have to search. Awesome. So we're down to number 12. Moving right along. 8 minutes has already passed. Wow, look at that. Okay, so this is a long one, but it's really not that bad. You just do it step by step. 2 boats are anchored 7 meters apart. They bob up and down. So they're 7 meters apart. They bob up and down, returning to their same position in 10 seconds. So they bob up, they bob down, return to their position every 10 seconds. So our period is 10. Okay, hold up on this wavelength because it's not 7 because they give you some more information at the end. I know you want to jump the gun and put 7. They don't. They leave something out. All right, the boats rise to a vertical distance of 7 meters between their lowest and highest point. So let's just illustrate that real quick. Bam, bam, bam. This is their highest, this is their lowest. They're saying the total from here to here is 7. That's not the amplitude, right? Because the amplitude is the middle to the top to the middle to the bottom. So that's half of 7 is our amplitude, which means our amplitude equals 3.5. Okay, cool. When one is up, this is the key to that first line. When one is up, the other is down. So it can't be 7, right? So let's say we have a boat here, and we have a boat here. They 7 meters apart, but they bob up and down, returning to the same position every 10 seconds. So really what we need to know is, remember, our wavelength is not top to bottom or bottom to top. It's same spot to same spot, right? So it's here to here. So we're actually going to have to double that 7. So our wavelength is actually 14. Aha, right? So they almost get you here. A lot of people put 7. Okay, let's see. We can do frequency, I guess. Let's just start knocking stuff out. Frequency equals 1 over period. Our period's 10. 1 over 10 is just 0.1. So my period equals 0.1 seconds. I'm going to do my units. That's meters. That's meters. And that's seconds. Wait a second. Did I just mess up? Frequency. Oops. I messed up. Make sure you smash that like button for mess ups. Okay. Alright. So, there are never any crests between the boats. Determine the blah, blah, blah. Alright. Period we determined. Frequency we got. That was that little mess up there. Wavelength we got. See, we're already doing it. Amplitude we got. Now we just need speed. So, really, we've solved everything except speed. So, velocity equals wavelength times frequency. We don't know our velocity, but our wavelength is 14, and our frequency is 0.1, which means we essentially just move the decimal. So, our velocity equals 1.4. And that is going to be meters per second because it is. Okay, cool. That's it. That was pretty easy, pretty straightforward. There's a lot of stuff to unpack, but you know, when you're done, you're done. So, great job, guys. If you got any questions, let me know. And goodbye.